Hey AP Stats, it's Mr. Luneski with Chapter 24. We're looking at comparing averages of different groups. Not a lot of note-taking here. We're just going to look through two examples, kind of show you the differences on where this kind of is different from one group. Very similar to how Chapter 22 was laid out. So all I'm going to do is just kind of quickly go through the four-box method, kind of show you what's changing. So basically, box one, our hypothesis, the ho-ha here, is basically still going to look the same. So now we're just comparing two groups. So that's when we get our mu1 minus mu2. And again, we can have stuff like does not equal 0, less than 0, greater than 0. Basically now we're just saying that there's a significant difference between the averages of two populations. Just like we did with Chapter 22 with the two proportion z-test, we need to make sure that we're still defining our groups. So tell me what mu1, tell me what mu2 is. So our conditions, our model, basically everything stays the same here. We're still checking for random, we're still checking for independent groups. So just like we did with Chapter 22, we need to make sure that populations less than 10%. For the nearly normal condition, those rules are still sort of being applied here, that we either need to know that each group has above 30 people for the sample size to be large enough, or we need to be told that they are normally distributed, or if I give you data and it's less than 30 pieces of data, you have to look at the histograms or box plots of both groups, and yes, you have to check them both and draw them both. Okay. So then, all of that stuff's met, you just say it's fine, conditions are met, we will use a t-model and a two-sample t-test. So the mechanics here, what we will actually run is under stat test, it's number 4, it's a two-sample t-test. The conclusion, we're still going to fail to reject, just like we did before with that p-value. And for confidence intervals, we're going to do this with stat tests, option 0, two-sample t-intervals. The degree of freedom is a little bit different for two groups. It's not as easy as n-1. It's actually a very complicated formula. If you want to see that formula, just come see me. I'm happy to show it to you. Alright, so we're going to take a look at an example problem here. I'm not going to go through the whole thing with you. I'm just going to kind of point out some key moments on where things sort of changed from older problems to this new chapter. So we have a situation talking about resting pulse rate for smokers and non-smokers. So we're told that smokers have an average of 80 beats per minute, BPM, with a standard deviation of 5. And then with our non-smokers, they had an average of 74 with a standard deviation of 6. And so the overall question is just asking us, is there statistical evidence of a difference? So remember, it's not necessarily taking a stance of one's bigger than the other, so we're just going to do a two-tailed test here. So again, we kind of have mu1 minus mu2 equals 0. Keep in mind, you can always write that as mu1 equals mu2, and mu1 does not equal mu2. You don't have to do the 0 thing. Over here, I want to point out two different ways you can define them. Mu1, I said, is the true mean of smokers' heart rate. And mu2, another way you could write that is the average heart rate for non-smokers. So you can use the phrase true mean, or you can just use the phrase average here. Either one works. Keep in mind too, you do not have to define this as a separate thing. You can kind of do the little sneak attack like we did back in Chapter 22, where you would say like between smokers, and then in here you would just say, you know, mu1 and non-smokers mu2. So you still need to just write your little sentence here, which we did. Conditions, so basically everything kind of just stays the same. We're talking about both sets, both groups of data. So I believe in the problem it does say, it says roughly, both sets of data were roughly symmetric. So that's kind of our nearly normal condition. Can assume independence, 10%, you know the drill, nothing exciting in there. So for the actual test, I wanted to show you on the calculator what that looks like. So we go to Stat, we go over to, where are we? Number 4, 2-sample t-test. So this one we have stats, we don't have data. So then our x bar 1 was 80. Our standard deviation there is 5 with an n value of 26. And then the x2 value was x bar of group 2 was 74. Standard deviation was 6 with an n value of 32. We are doing a two-tailed test. So I want to talk to you about this option here, pooled. This is something that we actually don't really talk about in this course. It's basically just always safe to leave it at no. There's never really going to be an instance where you have to switch that off to yes in this course, so just always leave pooled at no. And then as always, just hit calculate. And then it gives us all of our stuff. So remember, we are still using t values instead of z values, so we get that t score. Our p value, if you notice, is in scientific notation, so a really small p value. Notice that the degree of freedom, again, kind of wonky, kind of a weird decimal here. It's because it uses that weird pooled formula. So again, p-value low, reject the null, you know the drill. Want to show you confidence interval real quick as well. So the cool thing about these tests is that once you run the test, if I switch that over now to the confidence interval, some of you already discovered this. It's option 0, 2-sample t interval. And if you notice, all my data is there already. So the cool thing here, we can kind of just leave this alone. I want to say I ran a 95% confidence interval. Pooled again, just leave it no, and then just hit calculate. So keep in mind too, it does think a little bit longer now because of those t critical values. It's not as quick with the z's. And so we look at this, and remember when we interpret this, since we got 2 positive numbers here, and I did smokers, I believe, was first, minus non-smokers. So we are saying that we're 95% confident the average pulse of smokers is between 3.1 and 8.9 beats per minute higher than non-smokers. So here we used to have percentages when we did the 2-prop z-test. Now instead of having a percent, this is going to be whatever the context is. So for this particular problem, beats per minute. Okay, and then the other problem, instead of me giving you statistics, I gave you 2 sets of data. So now you just need to remember that this essentially is list 1, this is list 2. It says, do the chains have significantly different means? So again, they're kind of just saying significantly different, not necessarily saying one's better than the other. Talking about fat content in pizza chains. So this one is also a two-tailed test. So yeah, I don't really think there's anything crazy there. So here, what I want to point out to you, because this is a situation where I give you data and I definitely give you less than 30 values for each group, so you do have to look at the histograms. The Domino's histogram looked roughly symmetric. That seemed okay. However, the Papa John's histogram didn't really look very symmetric, so I did kind of note that in the conditions here. It just says Papa John's distribution does not. So anytime the distribution is kind of yucky, it basically just means we need a bigger sample. So we need a bigger sample to get an idea of the graph. But again, just proceed with caution. And then the rest of it's pretty straightforward. Just like before, when we're given the option of data or statistics, where are we at? You would just switch over to data. And then just say, oh, list 1, list 2. Frequencies, just leave it 1. Pooled again, leave it no, and then just calculate. So yeah, so that's about it. Again, same thing, we get a p-value that's very, very small, so we reject the null, there's enough evidence, blah, 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 blah. You know the drill by now, guys. Alright, so that's all for chapter 24. Thank you for watching. I know it, and now you know it.